So assume that you want to test a claim that the paired sample data comes from a population for which the mean difference is equal to 0. Compute the value of the test statistic, round intermediate calculations to 4 decimal places as needed. Okay, the following table shows the weight of 9 subjects before and after following a particular diet for 2 months. You wish to test a claim that the diet is effective in helping people lose weight. What is the value of the appropriate test statistic? Okay, so I want to first start by putting the before data into list 2 and then the after data into list 2. Then we're going to find the differences and put them into L3 by doing L1 minus L2. So let's put in our data over here. So stat, edit, make sure you clear out your lists. And so we're putting in our before data into list 1. 168, 180, 157, 132, 202, 124, 190, 210, and 171. Okay, our after data is 162. Okay, this person lost some weight. 178, he lost some weight. 145, he lost a lot of weight. 125, and so on. So you kind of want to look at, what's happening to the numbers as you're losing your weight. And then the last one is 163. So it's desirable that the weight goes down when we're doing L1 minus L2. So highlight L3, go second 1, which is L1, minus second 2, that's L2. And over here you notice most of these differences are positive. So even though you're losing weight, the difference in the before and after data is a positive weight loss, right? So this is really important when you're stating your claim. You don't want to say, hey, I want to lose weight, therefore mu difference is less than 0. You actually want to look at some of the examples, some of the numbers, and say, hey, I want a positive number over here. This person, he's the only one who actually gained weight, and no one's the same. So most of the people lost weight, and they had a positive difference because we do L1 minus L2. So it really depends on your context. Like if I'm looking at test scores and I want to see if this new method increased my test scores, then I want my test scores to go up, and I would end up with a negative number in L3 if it was effective. There's also some homework assignment where it just says, is it effective in like changing it in some way? So it doesn't specify that it wants it lower or higher, so you would have to just say is not equal to. So it just depends on the question a little bit. But our claim is that mu difference is greater than 0 because we want to see if it's actually helping people lose weight. So greater than 0 goes where? That is your H1. What's the null? So we already put our data in. We have the differences in list 3. Because it's dependent data, we're doing a t-test based on the differences. So go to stat, test, go to t-test, because we're comparing the mean, or looking at the mean of dependent data. This time we have we have our data in a list, so we want to choose data over here. What is our null hypothesis? Mu 0, which is the mean in the null hypothesis, so our mu difference is equal to 0. So that's correct. You can keep it like that. The list is L3 because that's where we put our differences. The frequency is 1. The alternate symbol is greater than. So you're going to change that to greater than, and then you're going to go calculate over here. So our test statistic, rounded to 3 decimals for t, is 3.156. Does that look like a usual or an unusual value? Unusual value. So remember, we made the assumption that there's no difference between between before and after data. We found an unusual value, so we're going to go back and say our assumption was incorrect, and therefore we're going to reject the null. Our p-value is the next line. That's 0.0 0.0067 rounded to 4 decimals. We can compare that with our significance level, which wasn't given over here. So we're going to compare it with what number?
0.05.
So 0.0067 is less than 0.05, less or equal. When the p is low, we're going to reject the null. Okay, our critical value. Is this left-tailed, right-tailed, or two-tailed? Right-tailed over here. What is the area in the right tail? Okay, if we're using the inverse t, we have to find the area to the left first. What's the area to the left? 0.95. What's the degrees of freedom? 8, right? There's 9 pairs, so degrees of freedom is 8. So let's go to inverse t, 0.95 and 8 degrees of freedom. Okay, rounded to 3 decimals. The 9 goes up to a 10, so this is 1.860. And you don't really need to write the 0 there, but you can. Okay, our critical value 1.86. Our test statistic is greater than that, so it falls into the tail area, which is our rejection area. So reject the null over here. And this is the fail to reject. All right, did our original claim include equality? No. Did we reject the null? Yes. So what is our wording? Yes, the sample data support the claim. And what's the claim? That the diet is effective in helping people lose weight. Right, let's look at the next question as well. So it says, determine the decision criterion for rejecting the null hypothesis in the given hypothesis test. So we're going to look at the test statistic over here. So suppose you wish to test a claim that mu difference, the value of the difference is d for a population of paired data is greater than 0. Okay, that's the claim. Given a sample of size 15 and a significance level of 0.01, what criterion would be used for rejecting the null hypothesis? Okay, so we have our alternate hypothesis is greater than. That means it's what kind of test? It's a right tail test. The area in the right tail is what? Okay, we're using matched pairs over here, looking at the differences between our sample data between those two pairs, and therefore looking for the mean value. That means it's a t-test over here because our population standard deviation is not known. So how do we find this critical value? We're going to use inverse what? T. What's the area? Area to the left, 0.99, and then the degrees of freedom? Right, just one less than our sample size. So let's find the inverse t. Of 0.99, 14 degrees of freedom. Rounded to 3 decimals, that's 2.624. So this is where our critical value is, 624, just one on the right. We're going to reject the null if what? If it's greater than 2.624. So choice A would be the correct one to choose.